Hi, my name is Gloria Headland, and I'm here tonight to talk to you about using SQLite in your Android applications. So SQLite is a widely used SQL database, SQL or SQL being structured query language. SQLite is available on every Android device, and it is automatically managed by the Android platform. This means that you don't have to install any extra tools or packages. You can just basically create your database, create your table, and get going with it. It also requires only a little memory at runtime, which makes it ideal for mobile platforms. So these are the main data types that are supported by SQLite: text, which corresponds to string values, integers, which correspond to longs, and reals, which correspond to doubles. And in SQLite, when you create a table, what you're going to be doing is creating a table and specifying what column names you want to have in the table. And for each column name, you're going to have to give that column name a type affinity, telling it what type you're going to be putting into that column. And it's important to remember that SQLite will not verify that the type written to each of these columns is of the defined type, of the type affinity that you have given it. So that's just something you're going to have to bear in mind. There are a couple other data types that are indirectly supported by SQLite, such as blobs and date time, that kind of stuff. I'm not going to cover those in my section, but you can use this link, and it gives you a good overview of what you can and can't do, what kind of data types you can use. So if you're going to use SQLite in your Android application, you are going to need to import this package, android.database.sqlite. And in particular, you will be using these two classes, the SQLite Open Helper class and the SQLite Database class. So the SQLite Open Helper class is the class that will create a new database using the onCreate method, and it will also update your database schema using onUpgrade. And I'm going to kind of gloss over onUpgrade. I don't think that you would be using it for your student choice projects because it's mostly something that you would be used if you're updating versions. You probably won't be doing that. So we'll kind of gloss over that. And then the SQLite database class has all the methods for inserting, updating, and deleting data from your database tables. There's also a couple methods that take direct SQL query language and execute them. And then there's these two query methods, one of which takes a SQL statement as its parameter, and the other one whose parameters specify the SQL query. And these two query methods return a cursor object. The query methods are basically used to get the data out of the SQLite database, and we're going to go over this. So, real quick, here are some SQL statements. So this is this is structured query language. It's not Java. These are some simple statements that if you were going to use SQLite, you would most likely be using something like this. Well, you would definitely have to create the table. So to create a table, you do create table, and then everything in italics here is whatever you're going to name these things. So your table name, and then in parentheses, what your column names are going to be, followed by the type that you're going to be inserting into that column. And then to insert into a table, you do insert into, and then your table name, and then a comma-separated list of columns that you want to be inserting into, values, and then the values that you want to be inserting into those columns. And obviously, you have to make sure that the values comma-separated list matches the columns one, because it's going to be inserting value 1 into column 1, value 2 into column 2, etc. Now, notice you do not have to insert, when you're inserting into a table, you do not have to insert values into every column. You can pick and choose. You can just insert values into a couple columns. The columns that you do not insert values into will just be null. Now to update a table, you do update, and then your table name set column 2 equals new value 2, where column 1 equals value 1. And to delete from a table, delete from table where column 1 equals value 1. So demo time. For this seminar, I created a simple app for record collectors just to store their records. There's no music actually being stored. They're just storing like the title and the artist and the condition, year, label of the records. And the source code is up online on the web page under sections. So I will first show you what this app does. It's not too fancy. This is the first activity screen. What you can do is you can either add a record or you can view the record collection. So click Add a Record. Say we can add in a Beatles album, add in the White album, put in a label, right? A catalog number, I don't know what that would be, like 101 or something like that. A year. The condition of the record, and hit done. The UI on this is not so great. It doesn't really tell you if you've done anything if you hit done, so I'm just going to hit the back button, and now we can view the collection. And sure enough, I inserted some other records before this seminar, and there's the Beatles album that we just created. So the other thing that you can do with this is you can click on a record, and then you can either update the condition of the record or delete the record from the database. So we'll go ahead and update the condition, say we've listened to it a bunch. Now it's very worn. Update. And oh, I forgot to show you that this G here is where the condition is. So the last thing you can do is go ahead and delete it. And now the record's gone. So that's all the app does. And it uses a SQLite database. So let's look at some of the code for this app. So you can see here, I've got 5, well, you can't see what they're all called, but I've got 5 Java files. The first one that I'm going to show you is I've got a record class. So this record class has these properties for my record: an ID, an artist, a title, label, catalog, year, condition. There's nothing too fancy in here. It's got a constructor, a bunch of getters and setters. So that's my record class, right? And then I've got, just the startup activity. There's probably nothing too interesting in there either. The class that does the real work is this thing called the Record Collection Data Helper. And this is analogous to, for those of you who've already seen the lecture, Dan's, I think he called it a DB adapter. So this is the class that is going to connect to the SQLite database. It's going to create it, connect to it, do all the SQLite work. And so the first thing to notice is that I'm importing these things here. Let's see. So I'm importing database.SQLite database, an SQLite open helper, a SQLite statement, and a cursor object. And then we can start reading through the class. Much like Dan does in his storage 3 example, I'm defining static final strings for my database name, my table name, and then all my column names. I don't think this is something you have to do, but it just makes it read a little better. And as Dan mentioned, for the key ID, if you're going to use an integer primary key auto increment ID, you do want to call that _ID. I don't think that's something you have to do, but it makes, I think SQLite recognizes the _ID. It makes, just call it that. It makes it easier. So I've got those static final strings. I've got a couple other things. I've got a private context. I've got a private SQLite database that I'm calling DB. You can see that up there. And then I've got these private static final strings. Let's see, I'm just going to try to get this so that you can see it a little better. And these are SQL statements that are going to create the table, insert a table, update an entry, and then below this off the screen is one for deleting the table. And what I do, well, specifically with the insert, update, and delete statements, these are static final strings that will be compiled in my constructor for this class. So they're just compiled once, and then you can go ahead and execute them, like my insert method and my update methods and my delete functions are going to be executing them. You can execute them as many times as you want to with different values, but they don't have to be recompiled. So this is a good way to do it, to create the SQL statements as static final strings, and then, for example, this insert string, this is just an insert SQL statement. So it's insert into your database table and then the columns that you want to be inserting into, and then it's got this values thing that's filled with question marks. Basically, my insert method is going to go ahead and bind values into those question marks at execution time. So that's my insert statement. Similarly, I've got an update statement. Remember, my app, the only thing it does is it updates the condition of a record. So that update statement is basically saying, update the database table, set the key condition to equal question mark where the key ID is question mark. And then I've got a SQL delete statement, which is just going to delete from the database table where the key ID is question mark. And I kind of glossed over the key ID. Let me just go back up there. So here's my record collection create statement where I'm creating the table. And the first column that I'm creating is the key ID, which is an integer primary key auto increment. And so that's where that's coming from. I know because it's a primary key, that's going to be a unique value, and that's the way that I'm going to be able to identify the records in my table. So that's what I'm using to delete one record and to set the condition of a specific record as well. So we've moved on to the class constructor. And in my constructor, I have a context, and I have a MySQLite database helper, which happens to be a SQLite open helper. It's from the MySQLite open helper class. And then I've got a SQLite database here. This DB is DB helper get writable database. And the other thing I'm doing in the constructor, like I mentioned before, is I'm compiling the insert, update, and delete statements so that before we execute them, all we have to do is bind variables. And so this here, the open helper, I'm calling it MySQLite helper, DB helper. I've actually defined a class down here which extends, much like Dan did in his example. Sorry, let me just find it. It's right here. Private static class MySQLite helper extends SQLite open helper. So this is that open helper class in which we are going to create the database. See this onCreate method, database exec SQL. This function here will just execute a raw SQL command. That record collection create was one of my static final strings that created the database. So this SQLite helper class is what's creating the database. So moving back up, go up to my insert. Sorry, I know it's an awful lot of code. But it's all online, and hopefully you'll get a chance to go through it. So to insert a record, I have a public insert method that just takes a record. And this is called by, I have an add record class. So it's the add record class, all it knows is that it has a record that it wants to insert into the database. And then this public insert class is going to go ahead and call a private method right down here, a private long insert method, and it's this private method that actually does the work of inserting the record into the database, right? And this private method has all the parameters such as artist, title, label, catalog, condition, etc., and it's going to take those those passed in parameters and bind them to that insert statement that I have, and then it's going to execute that insert statement. With this line here, return this insert statement, execute insert. And this statement is going to return the row ID of the row that the record is inserted into, and if the insert fails, then it's going to return a -1, a -1. So I'm using this row ID as my key ID, and I'll show you how I do that. So back up to the public insert record. So I'm saying long row ID equals insert, and then this is the private method that's going to return the row ID of the row that the record's inserted into. And so if that row ID does not equal -1, I'm going to go ahead and take that row ID, and now I can set that as the ID of my record. Because obviously when I created the record, I didn't know what ID it was going to have, as it wasn't yet in the database. So I hope that makes sense. And I did notice sitting in lecture today that Dan had a different insertion method, and his is probably better than what I have. So I'm just going to point that out. You can take a look at storage 3. So in his insert user method, he does this thing, content values vals is new content values, and then he just does vals put, and then he just has to put in, I guess, the index, whatever he's calling the column, comma, and then whatever value he wants to insert into that. So this is probably better because you know that you're actually inserting values right into the correct columns, and also I guess this protects against SQL injection attacks. So definitely take a look at his code. So then I've got these two methods for updating the condition of a record. And that's right here. I've got a public update method, which takes a record and a condition. And then it's going to call a private update method. And that's going to take the ID and the condition, and then this private method is the one that's actually doing the update, and it's binding the condition to the statement, and it's binding the record ID to that update statement that I have up above and executing that statement. Similarly, for delete a record, I also have two functions. I've got a public delete function here that takes a record, and then that public function is calling this private function that is going to actually delete the record from the database. So I'm basically just doing the public function, calling the private function. That's just a way of abstracting the work a step further. And then I just have a function for closing the database. So at this point, we have gone over creating a database, inserting data into the database, updating the table, and deleting from the table. And so the next thing that you obviously want to do is you want to find out what's in the database and display that information or use it in some manner. So we'll talk about data retrieval now. So to do data retrieval, the first thing that you could do is you could create a string array of result columns for the columns of data that you want to retrieve. Something like this. String array columns is new string, and then put in that the column names of whatever you want to retrieve. And then, so that's an optional step. If you don't do that, you can just set that to null, and it's going to retrieve all the columns for you. What you do need to do to get data out of a database is some sort of query. And you can create a cursor object to retrieve the results of a query. So that looks like this. Cursor is this .db query, and then table is your first parameter, and there's 7 parameters. They're all together. And what are all of the parameters? Let's see. Here's a table of the parameters. So the first parameter is the only one that you actually need to put in. Well, I mean, you need to fill in the rest as null if you don't decide to actually put anything else in there. And obviously, you do need the table name so that the query knows which table it's querying. So the second parameter, like I said before, is that string of column names, list of which table columns to return, and null will return all of your tables. And then the third one is a where clause, which is a filter for data selection, and null will select all of the data. And then that fourth one is going to be a string of selection arguments, and that's if there are questions in the where clause, this is where you put the values. For example, if I just wanted to pull out like the Frank Sinatra records from my database, I would have my third parameter there, the where clause, that would be key underscore artist, or whatever I was calling my artist column. And then the fourth one would be a string Frank Sinatra. Actually, that would be in a string array. And that would just pull those out. And then we have the fifth parameter is a group by string array. And then if you're using that, a string array for having. And then the last one is order by, which is a table column used to sort the data, and null means no sorting. Now I have string array at this order by, and it might just be a string. I'm not 100% sure on that. I do use that in my program, and I think it's just a string, so that could be a mistake. And I'll find out if it is, and I'll get back to you on that. But so a query returns a cursor object, and then once you have that cursor object, you can use these methods on it. Get count, that's a cursor, that's a method of the cursor class, and that will return the number of elements that are in the cursor. And then you can move between the rows of the cursor by doing move to first and move to next. And then this one here, get column index or throw, is an important method that will get you the column index for a past column name. And I'll show you how that's used in my program. So let's go back to Eclipse. And let's see. So this method here is my view collection method. And this is in my record collection data helper class, the one that we were looking at with everything else. And this method happens to return a list of records. So the first thing I'm doing here, is I am creating the string array of result columns that I want to be returned. And in this case, I don't actually need to do this because here I'm calling the string array, and it's actually got all the columns in it, and so you could just leave this as null, but I guess I figured I could show you how that was done this way in case you didn't want to return all of the columns. And so then I'm obviously creating a record list to store, an array list to store my records into. And here I've got that query. So cursor is this.db.query, database table, result columns, null, 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 null. And here I'm going to sort this by key artist, ascending. And then I get that cursor, and if anything's in that cursor, see cursor move to first, then I'm going to add each entry from the cursor to my list. And I'm going to keep doing that until there's nothing in the cursor. And then if the cursor does not equal null and the cursor is not closed, then I'm going to close the cursor, and I'm going to return a list of records. So this here, list add entry from cursor, well, this is a list of records, and so I need to make sure that whatever I'm adding from the cursor is a record. So entry from cursor, I guess that's something I have defined down here somewhere. Here it is. Private record entry from cursor, it does return a record. And so this method takes a cursor object, and then it creates a record by getting these parameters out of the cursor object and giving them to the record constructor. And so here is where I'm using that cursor get column index or throw. So basically what I'm doing is my record constructor takes an ID, an artist, a title, a label, a catalog, etc. And here what I'm doing is I'm going through this cursor object and I'm saying get the column index or throw. So get the thing that's in the key ID index, and then get a long, so I hope it's a long, and then put that there, and that's going to be the first thing that I pass into my record constructor, etc. So that's returning a new record. So I think that was all I wanted to show there. So I'm going to go back to my slides. Okay, finally, actually not finally, but the next step is going to be to display the data. And you guys are probably kind of familiar with this because the data is just coming back in a list. And so I'm just going to create a list activity. And I think many of you have already done that for NPuzzle. But we'll go through it. So I'm creating a list, and then I'm going to bind each object in that list to an item layout, use a layout inflator, and use a view holder. And I'll show you that real quick. So that is in this file called record collection view. And let's walk through this. There's a list of records, a private list, an entry adapter, and very importantly, a private record collection data helper called record fetcher. So this is, you know, the thing that I'm using to get the data. And let's see. I'm doing the work of querying the database in a runnable in a separate thread. And I'm getting the data in this getResults function here. So let's go down to find getResults. And here in getResults, I'm creating a new a record fetcher, which is a record collection data helper object. And here, this is where I'm setting that list of records to be the record fetcher view collection. So that view collection, remember, is returning a list of records. This is where I'm getting it. The next thing I'm going to want to do is display it. So let's see what my adapter's doing. That's here, my entry adapter, which extends array adapter. So that's got a list of record items. Here's the getView method. One thing that I am doing here is I'm creating a view holder object. And I just want to show you what this is real quick. So this view holder is something that keeps references to children views, avoiding find view by ID calls on each row. And this is something you might want to think about doing if you find yourself in a situation where you're trying to display a lot of objects from a list in a list activity, and there's a lot of detail in the objects, like meaning that the item XML file that you have for that object has a lot of fields. If you create a view holder, then you're only going to need to do that find view by ID once, and not each time you bring a list, an object out of the list. So I'll show you what I mean by that. So this view holder is a class that I created. It's right here, static class view holder. And all this view holder is it's 5 text views, right, to display the artist, title, label, catalog, and condition. And so going back up, here I've got my new view holder object, and then I'm going to just set these text views to be view find by ID, and then I'm going to go look in my XML file, my record item XML file. So that's this thing right here. I'll just flip over to it. So this is, just typical XML file. It's got a bunch of text views. So I'm just binding each one of these text views to the text view in my view holder object. So I'm just doing find view by ID once. And then when I get each record out of the list, now instead of having to do find view by ID again, all I have to do is set the text in the view holder text view to whatever I want it to be, like get artist, get title, get label, etc. And then return the view. And there is this view holder thing is something that I found in the Android documentation. I can't remember if it was under list activity or list view, but if you just Google view holder Android, there's stuff written about it. Okay, so finally what I did want to show you is how, purely for debugging purposes, how to use command line access. And Dan did go over this a little bit in lecture. Command line access is great just for debugging, so that you can play with your database even if your app isn't working. And it's you can only use it if you have a rooted device or an emulator that's running. You need a running emulator. So to use it, you bring up your terminal, and you need to go into the Platform Tools folder of your SDK. So mine is under, Applications, Eclipse, Android SDK, Platform Tools. Okay, and then here you need to run your ADB shell command. On a Windows platform, I believe it's just ADB space shell. On a Macintosh, it's /ADB shell. And once I'm in here, I can do things like ls, right? And to get to my SQLite database, you actually need to go to cd data/data, and then you need to find your package name. So mine happens to be this one, com artisanal apps down here. So cd com artisanal apps. And then finally, you go to the databases in there. And now this databases, that's only going to appear if you've actually created a database in your Android application. So if all you see is library, that means that you have not created a database yet. There doesn't have to be anything in the database, but you do have to have created it. So now we can go into the database and see what's in there, and sure enough, there's my database. And at this point, you can connect to it doing SQLite 3. Don't forget the 3 there. mycollection.db. And here I am in my SQLite database. So it says enter .help for instructions, so you can enter .help. And this is going to give you a list of all the commands that you can use that are preceded by a period. Like the useful ones I found are, let's see, .database. I think it's .database. Yeah, .database will tell you what databases you have. .tables will tell you what tables you have. So notice there's an Android metadata table, which I didn't create. I guess the Android operating system created that, and then my records, the table I did create. The Android metadata table is, I think it's something for language or localization. I've tried looking in it before, and yeah, it just said like EN/US. Actually, we can look in it right now. So these are some commands that you would use. This is SQLite commands that you could use here. So to see in the Android metadata table, for example, I would do select star, meaning all, from Android metadata. And you do need to put a semicolon at the end. If you forget the semicolon, it's just going to bump you down to the next line, but you can put the semicolon down there. And that's all that's in there, in _US. So I think it's got something to do with localization. Anyhow, let's see what's in my records. So select star from my records. And there's my record collection. And then here you can do your deletes, your updates. You can practice your SQL commands. And then to exit out of here, it's just .exit. So that's about all I had. Were there any questions or anything else? Okay. So, well, thank you.